In this lecture, we are going to discuss complex number. In the number system, we are going to discuss complex number. So complex number is the next number system. The first number system is real number system, which already we have studied, and the second number system is complex number. So let's define what is a complex number. The ordered pair of any two real numbers. The ordered pair of any two real numbers is called a complex number. It is generally denoted by Z, capital letter Z, W, etc. Let's look at example. According to the definition, the ordered pair of any two real numbers. Let's take A and B, any two real numbers. Then ordered pair of the two real numbers A and B is called complex numbers. A comma B is complex number because it is an ordered pair. X comma Y, 1 comma 2 minus 3 comma 4 are examples of complex number. Let's define real part and imaginary part. The real part of complex number. The real part of complex number is the first component of complex number. That means if x comma y is given a complex number, then the first component, that means x is called the real part. The first component of a complex number is called real part. Imaginary part. The second component of a complex number is called imaginary part. So if x is real part, then second component y is the imaginary part. The second component is called imaginary part of complex number. Imaginary unit. The imaginary unit is a complex number. It is denoted by the letter I. It is called also iota. The complex number having real part 0 and imaginary part 1 or unity is called imaginary unit. A complex number having real part 0 and imaginary part 1 is called imaginary unit. Example, the complex number 0, 1, according to the definition, the complex number 0, 1 is imaginary unit, and we denote it by letter I because it has real part 0 and imaginary part 1, or we can say unity. So 0, 1 is known as imaginary unit. The complex number having real part 0 and imaginary part 1 is called imaginary unit. So 0, 1 we can denote by I, and 0, minus 1 we can denote by minus I. The real part is 0 and imaginary part is minus 1, so we can denote 0, 1 by minus I. Now let's learn the addition and subtraction rule of complex number. Number first, A comma B, the first complex number, plus C comma D, the second complex number. A comma B minus C comma D. That means when we add any two complex number or when we subtract any two complex number, then we follow the same rule. So the sum of A comma B and the second complex number C comma D will be A plus C comma B plus D. That means according to the rule of addition, we have to add the real parts with the real part and the imaginary part with the imaginary part to get the sum or to get the difference. So A comma B plus C comma D, we can write A plus C comma B plus D. That means adding real parts, adding imaginary parts. Then we get the sum. Similarly, the subtraction rule. A minus C comma B minus D. That means we take the difference of real parts and we take the difference of imaginary parts to get the real part and imaginary part. So this is the rule of addition and subtraction. Let's go to the multiplication rule. According to the multiplication rule of complex number, A comma B into C comma D. That means if any two complex numbers are given, then in order to multiply them, we use the rule AC minus BD. That means we take the difference of the product of real parts and imaginary parts, comma. So this is the real part of the product of two complex number. Then imaginary part we get AD plus BC. That means we take the product of real and imaginary. Again we take the product of imaginary and real of the first two given complex number. So this is the multiplication rule. A into B, A comma B into C comma D. A comma B into C comma D we can write as AC minus BD comma AD plus BC. So this is the multiplication rule of complex number. Properties of complex number. The first property is I square is equal to minus 1. The value of square of imaginary unit is equals to minus 1. Or we can write I is equal to root of minus 1. The imaginary unit I is equal to root of minus 1. Number 2, if a comma b is given any complex number, then we can write the given complex number in the form of imaginary unit. That means a comma b we can write as a plus ib. So a comma b and a plus ib both are same. They represent complex number. Let's look at the proof of the first property. I square, the value of I square is minus 1. Solution, we know that I, the imaginary unit I is the complex number 0, 1, which has real part 0 and imaginary part always 1. Now I square, let's take LHS. I square is equal to I into I. So the value of I is 0, 1, 0, 1 into 0, 1. So 0, 1, let's suppose as a comma b into the second 0, 1, let's suppose c comma d, so that we can apply the multiplication rule. According to the multiplication rule of complex number, a comma b into c comma d, we can write ac minus bd comma ad plus bc. So ac minus bd means ac, that means 0 into 0, minus bd, bd means 1 into 1, so 0 minus 1. So ac minus bd is 0 minus 1, and ad plus bc is equal to 0 plus 0. ad, the value of ad means 0 into 0, 0, plus bc, b into c, that means b into c, that means 1 into 0, we get 0, so 0 plus 0. So we get, after calculation, we get 0 minus 1 means minus 1, comma 0 plus 0 means 0, minus 1 comma 0 we can write as minus 1. So if the imaginary part of any complex number is 0, then the complex number we can denote by real part. So real part is minus 1. So I square, the value of I square is minus 1 comma 0, or we can write it as equal to minus 1. The second property is, if a comma b is given any complex number, then we can represent it by writing a plus ib. That means we can write the given complex number in the form of imaginary unit I. So let's see the proof. Let's take LHS at first. Solution, a comma b LHS. So a comma b we can write as a comma 0 plus 0 comma b. The sum of two complex number a comma 0 plus 0 comma b will be again equal to a comma b, because a plus 0 is equal to a, 0 plus b is equal to b. So breaking down into two complex numbers. So a0 again we can write as a times 1 comma 0 plus 0 comma b we can write as 0 comma 1 times b. Now 1 comma 0 we can write as 1, because imaginary part is 0, so we can represent by real part 1. 1 comma 0 we can write as 1, so we get a into 1. 0 comma 1, by the definition of imaginary unit, 0 comma 1 is the imaginary unit I, so we can represent it by I into b. So a into 1 a plus I into b ib. So a comma b we can write as a plus ib. Note, the complex number having imaginary part 0 is denoted by the real part of the complex number. That means if the imaginary part is given 0, if imaginary part of any complex number is given 0, then the complex number we can represent by the real part. So 1 comma 0 is equal to 1. 2 comma 0 we can write as 2. In this lecture we are going to define conjugate of a complex number. If z, that means complex number, if z is equal to a plus ib be the given complex number, then the conjugate of z is denoted by z bar and defined by z bar. That means conjugate of z equals to a minus ib. That means conjugate of a plus ib is a minus ib, and the conjugate of a minus b is a plus ib. Example, the conjugate of 2 plus 3i is equal to 2 minus 3i. Next, we are going to define modulus of a complex number. If z is equal to a plus ib, that means if the given complex number is z is equal to a plus ib, then the modulus, or we can say absolute value of z, the modulus of z is denoted by writing two vertical lines, or we can say two vertical bars z. So modulus of z, or we can say absolute value of given complex number z, and defined by modulus of z is equal to root a square plus b square. So if z is equal to a plus ib be the given complex number, then the modulus of z is denoted by this type of symbol and defined by modulus of z is equal to root a square plus b square. So geometrically it gives the distance of the complex number from the origin. So modulus of z is equal to root a square plus b square. Now important properties of complex number. Modulus conjugate of z1 plus z2, we can write conjugate of z1 plus z2. Conjugate of product of z1 z2, we can write the product of the conjugate of z1 into z2, we can write z1 bar into z2 bar. The conjugate of the product of two complex number, we can write as conjugate of first complex number into conjugate of second complex number. The third property is z into w. The modulus of two complex number is equal to the product of modulus of first complex number and the second complex number. Fourth property, the modulus of z by w. That means if z is divided by the second complex number w, then we get modulus of z divided by modulus of w. And the fifth important property of complex number is the conjugate of any complex number. That means the double conjugate of any complex number is the complex number itself.